Next is the discussion of weighted voting system and the measurement of power. In this slide, I included the principle of one person, one vote. This is to emphasize that not all voting systems adhere to this kind of principle. Rather, voting systems like weighted voting system means that the voting rights among all voters are not equally divided. An example of this is the corporate shareholders meeting, wherein yung power is determined rather by the amount or value of his or her share sa isang corporate. So basically, when we say weighted voting system, all we need to do is to consider who has more power, how is power measured, and if there is a mathematical treatment of power. Next, when we also say weighted voting system, there are three ingredients. One of the ingredients is the players, which are the voters of a votation. Next, we have the weights, which is the players' control over a number of votes, and then the quota, which could be represented by Q, which is the total minimum number of votes necessary to pass a motion. Ito yung number of votes na dapat ma-reach in order for a person or a proposition to win the votation, which is usually higher than 50%. So dito sa example na meron tayo, we can see the number 13, which represents the quota. Next, we have the numbers 8, 6, 4, 3, 2, 1. Each number is one player. And yung 8, yung value ng 8 is the weight na meron yung isang player. Next, we have the concept of bands of index and the mathematical measurement of power. So, ito ay isang method na produce ng isang lawyer, namely John Banzhaf. So, dito sa example na meron tayo, we can observe that the first column is the coalition. Next, we have the column of weight. Then the winning or losing column. Dito sa coalition, we have A, B, C, D, and so on. We have the P1, P2, P3. Itong mga to are coalitions because they are any set of players na nag-join force in order to vote together. So, yung weight ng player 1 is 48, player 2 is 47, and so letter D coalition, we can observe that yung weight is 95, which is the sum of 48 and 47. So basically, yung 48, 47, and 5 na weight ng player 1, 2, 3 are considered losing coalitions because it does not meet the quota. Next, we also have the coalition D, E, F, G, which are the winning coalitions. So, we also have the concept of critical player. Itong critical player, it basically means that a player is necessary in order for a coalition to win. Next, for the next slide, we are going to discuss about the bands of power index. We have the concept of bands of index as well as the bands of power distribution. So bands of index is the player's power is proportional to the number of times the player is critical, while bands of power distribution is the distribution of power among players. So if we are going to look at the example a while ago, we can see that the player 1 appeared 4 times as well as the player 2 and 3, and the total, so basically the bands of power distribution is 12 and the bands of index is 4, so that is 4/12, and if we are going to round it off, or in a simplest term, we are going to get the 1/3, which basically means that the critical aspect or amount of each player or up to 1/3.
The final section deals with division problems. To start off, fair division is an area of mathematics that deals with problems that involve the division of a certain set of goods among individuals that would be considered fair by the parties involved. Let us take, for example, the famous story about the dead father, his sons, and his camels. 3 sons were left with 17 camels, but they did not know how to fairly distribute it, as 17 could not be divided. Luckily, a wise man came and helped them solve it. The solution of the wise man was fairly easy. First, he added his own camel, making them 18, and then he solved for the proportions. 1/9 of 18 is 2, 1/3 is 6, and 1/2 is 9. Add them all up and we get 17. The wise man took his own camel and then left. The three children were left satisfied. One assumption in fair division is that a fair share is any share that, in the opinion of the player receiving it, is worth at least 1 over n of the total value. A fair division scheme has four properties. It is decisive, internal to the players, assumes that the players have no knowledge about each other's value systems, and finally assumes that the players are rational. There are two types of fair division problems. Continuous fair division problems are where infinite number of ways and shares can be increased or decreased by arbitrarily small amounts. Example, land, cake, and pizza. Discrete, on the other hand, involves indivisible objects like cars, houses, and boats. Under discrete fair division problems, we have apportionment. It is the process of allocating identical, indivisible objects among participants entitled to unequal shares. Example, congressional seats in the United States. Allocating congressional seats, we use two ratios, standard divisor and standard quota. Standard divisor is the ratio of population to seats. It is the average number of people per seat. Standard quota is the ratio of state population to standard divisor. It is the exact fraction of the total number of seats a state would be entitled to if seats were not indivisible. The formula for these two ratios are shown on your screens. To understand the concept of standard divisor and standard quota, let us have an example. It is the year 1790 and the US population is 3,929,214 and the House of Representatives is to have 105 members. What is the standard divisor? What is the standard quota if the population of Virginia is 747,610? Using the formula for standard divisor and standard quota, we arrive at a conclusion. The standard divisor would be 37,421.09 or 37,421. Virginia would have 19 representatives at minimum or 20 at maximum. It would be dependent if they would choose their lower quota or upper quota.